Chapter 12, Section 2, we are looking at translations. And we start out with this example. We start out with triangle ABC, and first we reflect it over line M. So we're going to start out with this triangle, and if you remember, we trace that segment, the exact length, and then we trace the triangle, and then we take the paper, tracing paper, and flip it over and line it up, and then we trace the triangle again. So these should have letters in here. We'll call it ABC, and what I've just created is A prime, B prime, C prime. So I took the triangle, reflected it over the line, and that became A prime, B prime, C prime. And now I want to take A prime, B prime, C prime and reflect that over line N. So I'm going to start again drawing my segment, the exact length, and then A prime, B prime, C prime, and then I flip my tracing paper over, and this would be C double prime, A double prime, B double prime. And I'm going to color that a little bit darker and shade it in. And if you'll notice, from this original shape to this shape, if we reflect over two parallel lines, that is the same thing as a translation, or sometimes called a slide. A translation is an isometry where all the points of a figure are moved the same distance in the same direction. And because we perform two reflections consecutively or at the same time, we can write this notation a little bit differently. We can say we started out with triangle ABC, and the first thing we did was reflect it over line M, and then we reflected it over line N. Or another way you can say that is that you took triangle ABC and you reflected over line M, and then you reflected over line N. So we started with this triangle, reflected over line M, then reflected over line N. And the next couple questions say, tell whether each transformation appears to be a translation. And if you remember on your test, you're going to have to say what type it is. This is not a translation. It's actually a reflection. This one is a translation, so that would be a yes. And you'll see I drew that arrow there. That's sometimes called the vector. This one is not a translation. It's actually a rotation. And this one is a translation, and that would be the translation vector. There is another way to perform a translation. You place your tracing paper over the top of the triangle, and then you trace triangle ABC, and then slide your paper towards it. So what we can do is, if we started again with triangle ABC right here, sorry if you couldn't see that, triangle ABC, you could just take it and slide it and they should match up. The line that you slide along is called the vector, and vectors have direction and magnitude. And by magnitude we mean size. So they tell you one direction and then how far to go. So at the top of our next page we have some translations that we are asked to draw. And what you do is you trace the shape. So So here I trace the rectangle, and then you trace the vector. And then what you do, I'm gonna just flip my paper over and trace across that again. So I flipped it over and I colored on the other side. And now we take this vector and we slide right along until we are at the end of the vector on the bottom. And then you trace over that, and that will be your translated shape. Letter B, we're going to trace the vector and then the shape, and flip it over and trace on the back side. And now we take that and we slide right along that vector till we get to the end. And then we trace the shape, and that will be our translated shape. Next one, you are going to trace the triangle and the vector, and then you take your vector and you slide. And I think I forgot to color on the back side. I'm going to trace over it really dark. Nope, didn't work. Flipping it over. Trace along the vector. And there is your triangle right there. Now sometimes if you don't have tracing paper, you can kind of sketch it. So I'm going to have this one, that point be translated, this point be translated, that point be translated, and that point be translated. And obviously that's a sketch, not too bad. So you need to go the same distance and the same direction. A translation is two reflections over parallel lines. And if you look back at our previous page, we reflected once and then again. That was our translation over parallel lines. And a translation magnitude is twice the distance between the parallel lines. And now we have some translations in the coordinate plane. When dealing with a coordinate plane, translations are very simple. The vector is given as an ordered pair, so the vector is given as the ordered pair. That means the pre-image moves 1 unit to the right and up 2 units. And there's a second notation. If you're going to translate a point AB along the vector xy, that would become A plus X and Y plus B. So let's say we had the point, I'm going to say we had the point -2, 3. So -2, 3 is right here. And you want to translate that along the vector 1, 2. So we start with -2, 3, translate it along the vector -2 plus 1, 3 plus 2. Our new point would be -1, 5. I think I did, oh no, -1, 5. Which would be right here. And you'll see we moved 1 to the left and then up 2. And we have a couple more of these examples up here. We're taking triangle DEF. So I'm going to start by drawing triangle DEF. -3 excuse me, -3, -1 is D. 5, -3 is E. And then -2, -3 is F. So that's our first triangle. And we're going to translate that along the vector 3, -1. So we're going to add 3 and subtract 1 to each of these. -3 plus 3 is 0. -1 plus 1 is -2. 5 plus 3 is 8. -3 plus -1 is -4. -2 plus 3 is 1. -3 plus -1 is -4. And graphing that, you have 0, -2.
J.T. Williams, please come to the office for a message. J.T. Williams, thank you.
8, -4 is over here. And then 1, -4. And I probably should label my D prime, E prime, and F prime. And that would be your image. Pre-image is the one you start with, and that would be the image. Letter B, we're going to graph the ordered pair 2, 5, which is R, 1, -1, which is S, and 3, 1, which is T. So there's my triangle. And then I am going to add -3, -4 to all of these. 2 plus -3 is -1. 5 plus -4 is 1. 1 plus -3 is -2. -1 minus 4 is -5. 3 plus -3 is 0. And -4 plus 1 is -3. So our new points are -1, 1, which is R prime, -2, 5, which is S prime, and then 0, -3, which is T prime. I think I did -2, 5 wrong. How about down here? -2, -5, which is S prime. And that's the nice thing about these, is if you end up with a different shape, you've obviously done something wrong. So there's my pre-image and then the image. Example 4, in a marching band drill, a drummer starts 8 steps to the left and 8 steps up from the center of the field. So it starts at 8, 8. Then she marches 16 steps to her right. You know what? Problem here. The center of the field would be right here at 0, 0. So if the drummer starts 8 steps left, they would be right here at -8, 8. So we start at -8, 8. She then marches 16 steps to her right and 24 steps backwards to be at her last position. So this is where she started, and then they were translated along the vector 16 and 24 steps backwards would be -24. So if we do -8 plus 16, she would be at 8. 8 minus 24 is -16. and the vector that describes the moves is right here, 16 steps to the right and then 24 steps back. And number 5, a sailboat has coordinates 100 degrees west, and let me just draw north, south, west, east. So 100 degrees west would be negative 100, and 5 degrees south would be negative 5, which is your starting point. 50 degrees west would be 50. 10 degrees, oh, I did that wrong again. 50 degrees west would be a negative 50 because you're moving further in this direction. And then 10 degrees south would be a negative 10. So if you started out 100 degrees west and you went another 50 degrees west, you would be negative 150. And then if you were 5 degrees south and another 15 degrees south, you would be negative 15.